Okay, everybody, let's get started. Greetings, I am Joe Murphy, Vice President of Marketing at Sensory, and I'm excited to welcome all of you to our webinar, Rapid Prototyping of Voice Solutions with Sensory's VoiceHub and Ambiq's Voice on Spot. Today, you will hear from two leaders in their respective industries, Sensory for AI on the edge, and Ambiq for ultra-low power MCUs and wireless SoCs. Sensory will provide a walkthrough of the VoiceHub portal for building voice AI models, and Ambiq will demonstrate these models on the Voice on Spot development kit. Before we get started, a few general housekeeping rules. All attendees will be muted during this webinar, but we do encourage participation. So if you'd like to ask a question, please enter the question in the chat window. We have reserved 15 minutes at the end for Q&A. Also, this webinar will be recorded and the link will be available for viewing and download. So now let's meet our panelists. And first we'll start with Jeff Rogers.
Hey, good morning, everyone. Thanks, Joe. So Jeff Rogers, Vice President of Sales and co-founder of Sensory. Excited to be here today. This is going to be a really interesting and fun webinar. We're going to introduce you to our new VoiceHub tool, which is already changing the way that a lot of companies do product development and ideation around adding voice to products.
Okay, great. And now to Mark Miller.
Hi, I'm Mark Miller, Director of Solutions Marketing at Ambiq. During my career, I've always worked at chip companies, usually looking at things from a system solutions viewpoint. Last 5 years, I've been concentrating on AlwaysOn Voice, the audio signal chain for battery-powered products. At Ambiq, I work with a very inventive group of engineers on these audio products, and then also we collaborate with industry-leading providers like Sensory, as we're going to do today, to provide solutions. And we look at the solutions that work well from a user viewpoint, and then we go through all the hurdles to qualify in the audio lab for the requirements that we all face today. And then encompassing all of that, we're always keeping an eye on power, and every step of the way, we're trying to wring every possible microwatt of power out of the system.
All right, thank you, Mark. And finally, let's meet Gary.
Hi, I'm Gary Allen. I'm an FAE with Ambiq and I'm based in California. Before joining Ambiq, I spent many years in embedded development and support, including audio and Bluetooth.
Okay, thanks everyone. Let's get started with Jeff at Sensory.
Okay. Just want to make sure that you can see my slide there, my PowerPoint.
Yes, looks good, Jeff.
Okay, great. So, quick intro to Sensory. We're a privately held, profitable company. We got started back in '94, actually as a chip company, and so it gives us a nice background working with our chip partners like Ambiq, where we have a basic understanding of chip and low power platforms, and that's where we started. And so rather than starting in some cloud or server-based solution and trying to figure out how do we cram this to get down on these really low power devices like the Ambiq device, we actually started as a chip company. So we have a lot of that experience in our background, which has been great. We're focused on really improving the user experience through voice and vision technologies. And 26 years ago, it was a little more challenging because we had different platforms to run on, and people weren't as used to or comfortable with talking with products as they are today. And so a lot's changed over the years. So it's been a really interesting and fun ride. We've got around 58 employees and 3 main offices in the US, and then we have some satellite offices around the world. So global brands rely on Sensory. You can see here that we work with a lot of different companies and across a lot of different markets, from mobile to wearable to IoT, appliance, automotive, finance, some healthcare in there as well. And these are all real customers doing real products. They're not just a demo that was done here or there. These are again real products that have shipped to volumes of people. Across our lifespan, we've done more than 3 billion products worldwide, and it's been a lot of fun. And again, here you can see kind of a nice mix of customers that we work with. The digital giants trust Sensory. I don't think that there's another company that can make the statement that we're making here, where all of these digital giants use and have used Sensory as a front end to to their cloud assistants as well. And some of these use us exclusively, some along with their own technologies, and some with other third parties as well. So why voice, why now? You know, in our history as a company, there were a couple pivotal, I guess, events that really changed the kind of the broader scope of things. And I'd like to say that Sensory changed it all, but I can't take credit for it. Apple, when they came out with Siri, even though it didn't work very well and a lot of people had problems with it, Apple did such a great job of marketing it that kind of the general consumer became aware of the value of voice and talking to things. And then, of course, with Amazon's Echo and the whole smart speaker explosion, people not only became used to it, but started to expect it. And both of those have been very helpful for our business as well. And so again, driven by the smart speaker growth, voice really is becoming and has become the preferred method. And you know, obviously voice provides the most natural interface and also allows for hands-free. VoiceHub is changing the way that companies already do ideation, as I talked about, and product development and demos and proof of concepts. We've removed, with our VoiceHub, we've now removed the friction points of longer development and costly development and other factors that used to slow companies down in kind of considering and thinking through. Do we want to add voice? How do we want to add it? Do we like the flow of voice in the product? Do I like this wake word followed by these commands over here, or this natural language interaction following that? And again, in the past, it was kind of, well, let's do it on a flow chart. Let's look at visually. Well, now you can start there, and then you can very quickly put it into a functional prototype where it's like, now let's talk through this and test through it. So it really is it's a huge change for us and for the industry. And then Sensory, through our partnership with Ambiq, can provide this on one of the lowest power platforms in the industry today. So hands-free, truly hands-free. This is our low power, high accuracy wake word. This is shipped in billions of products, as mentioned. And as Joe likes to say, and I've taken over his comment here, it really is a mini marketing moment just waiting to happen each time. We're really big on custom wake words. We feel the value that companies should own their brand, control their brand, that customers should be able to say the wake word of the brand, either the brand name or the product name. And so we do a lot of custom wake words today, and truly hands-free, again, is designed around that specifically. There are several technologies that are included in truly hands-free. And don't worry, I'm going to get to the VoiceHub. It's really cool, but just a little background here first. First off, a fixed wake word. So a fixed wake word is a wake word that works right out of the box. I don't have to enroll. I don't have to, install an app first. I don't have to go to the internet. I just get the product and I either plug it in or turn it on, and I just have to know what to say and I start using it. So these are obviously very common. An enrolled fixed wake word starts as a fixed wake word. So I have that out of the box experience, but then I can allow the user to enroll their voice, their accent saying the wake word. After that, it provides a couple of different things. Number one, obviously it adapts to that user's voice and accent. And secondly, it allows speaker identification and speaker verification. So not only can I say the wake word, but the product can say, oh, I heard the wake word and I know that it was Jeff saying the wake word. User-defined wake word is language independent. So if I want to do a product that I can use anywhere in the world today, I can use our user-defined wake word, allow the user to define that wake word on their own in any language they want. If I want to speak Klingon to my product, I'm going to speak Klingon to my product. And as a Trekkie fan, okay, it's pretty cool to do that. And then speaker verification, this can be combined with a wake word where it says not only was the wake word said, but I'm confirming it was Jeff that said the wake word. And then finally, phrase spotted commands. Phrase spotted commands are really cool. And I'm going to show you demos of all this in our VoiceHub in just a minute. But a phrase spotted command is where I define a certain number of commands. And then the technology is designed such that it will spot that command among other noise and things around it. So I've got a really cool smartwatch demo that I love to show at like really noisy trade shows. And back when we used to go to trade shows. And it's got like step count and calories and heart rate. But I can just say things like, hey, what's my step count today? And it spots step count out of the middle of that. And so again, whether I'm in high noise or whether I'm speaking naturally to it, I can spot those commands. And a lot of times people will say, oh, wow, so this has got an NLU running in a smartwatch. No, no, no. It's truly hands-free with phrase spotted commands that has the feel of a full NLU engine behind it because it has that ability to spot commands. I won't take too much time talking about our other technologies today since we're focused on VoiceHub and with our partner Ambiq, but I did want to mention our Truly Natural. So Truly Hands-Free is all about wake words and small command sets and everything that we do, everything we're talking about today is on device. So there's no cloud component required. Truly Natural is our large vocabulary embedded engine that can handle thousands and tens of thousands and hundreds of thousands of commands on device. And so we can combine this with our Truly Hands-Free such that you have a wake word, you have some small commands if you need to, running very low power, such as on the Ambiq chipset. And then we can run Truly Natural on the application processor where I've got a natural language engine that does have NLU in it. There's a microwave that's just starting to hit the market from Faberware that's using our Truly Natural. And this is great because this is the world's first microwave oven where you get the product, you take it home, you set it on the counter, you plug it in. Okay, now, first thing you do with a microwave is you got to set the time. Well, instead of figuring out, okay, where's the clock button and how do I up the time or do I push buttons to do it? Guess what? You say the wake word and you just say set time to, let's see, 9:14 a.m. and the time is set. I mean, it's brilliant, just setting the clock. And then, of course, because it's got the full Truly Natural engine, I can say things like cook for 35 seconds or cook 3 baked potatoes or defrost a 1-pound chicken or cook my 3.5-ounce popcorn. Again, it has that whole ability built in. There's no apps, there's no internet connection, there's no complicated setup. I buy the product, I start using it. This is our Truly Natural. And so my example here is set the temperature to 72 degrees. We could do a very small IoT-based product that controls lights and temperature and garage and security system, where the whole thing is probably around 3 megabytes. That's 3 megabytes, really, really small. And then our Truly Secure. This is our biometric security solution. We provide both computer vision as well as speaker verification technologies combined into one solution. And it allows us to combine these with our other technologies such that I could combine this with a wake word, I could combine this with our Truly Natural, or we can just use it independently. There are many banks around the world today. Some of the largest banks in Japan and Mexico, as an example, Mizuho and Banorte, that are using our Truly Secure to replace usernames and passwords, because I know how much we all love those. So some pretty cool things that we can do with Truly Secure. Okay, so let's get into the VoiceHub, and I'm going to exit out of this PowerPoint here and go to my actual screen here. So hopefully we can see all of this. So this is the VoiceHub. It runs online. And I'll tell you more about how to log into this in a minute. But basically, I'm already logged in, and then I can start a new project as an example. And here you can see I can create a custom wake word. I can create some simple commands, and then this whole section here will be added next month. We're introducing this at CES next month. This is our Truly Natural, which is being added to our VoiceHub. But today I'm going to focus on wake words and commands. So the first thing I do is I select that I want to do a new project. So then I can go in and I can name it whatever I want, test as an example. And then I can select the language that I want. So here you can see that I've got all these different languages that are already included in VoiceHub. Today, Sensory supports 24 languages and many, many dialects around the world. And we've added all of these so far to VoiceHub, and we will continue to add languages. For Gary, I might select the UK English engine, but for me, I'm going to stick with US English here. Next, I can select the size that I want. So you can see the sizing ranges from 80 KB up to about 1 megabyte. And so because I want to focus on the Ambiq platform and I want it super low power, I want to keep my model as small as I can, I'll go with the 80 KB. And you can see that the output format I've selected as Ambiq already. And I can select our Sensory SDK that people can use, or we also work with a variety of other chip partners. Today, we're going to focus on Ambiq. Here you can see the number of operating points. So there's 2 options here, a single point and all points. So what this means is when we create a wake word, we provide a series of search points. So think of it as on a graph, a frontier graph, where on the one side you've got false reject, and across the bottom you've got false accepts. And I always tell people it's not hard today to create a wake word. I think just about any company can, but it's really hard to make one that works well. And so what we do is we create this frontier graph that has a range between false accept and false reject. And the tool will automatically, if I do this single point, will automatically select the best point on that line that balances between false accept, where I'm just talking and it says, oh, I think I heard the wake word, and false reject, where I say the wake word and nothing happens. And again, you want the kind of that middle ground between those. So this is the recommended, and it's a much faster option in development. Or I can get all of the search points, where as a developer I might say, well, I'm going to put a front end mic array or front end noise canceling or something else in front of the sensory engine. And so having access to all the search points allows me to pick, well, here's the recommended one, but I think it's actually going to work better if I move up this way or down this way. And so I'll just stick with this one here. So then I just type in the wake words that I want. So I can say, okay, sensory. And then I just hit return and it drops me down and says, okay, now if I want to add another one, great. I want to do 2 wake words running at the same time. So I can do, hey, Ambiq. And notice that I'm going to spell Ambiq phonetically. I won't put it with the Q. I haven't actually tried it with the Q. My guess is it would still work. That'd be an interesting thing to try. And then again, I hit return, and now it's ready to go. On the side over here, you can see these little speakers, and what this will do is, using a TTS engine, it will pronounce as sensory thinks that the word should be set. So as an example, if I push this,
okay, sensory.
Sorry, I hit it twice.
Okay, sensory.
So again, it's just basically so that I have an audible cue as to what I think it's going to sound like. So if I'm typing in a word that's either a made-up word or a company name or a product name, I can hit that just to basically hear what the sensory engine is going to think that I'm saying. So I can do the same with Ambiq here.
Hey, Ambiq.
So hey, Ambiq, yep, that sounds right. That's what I would say. That's how I'm going to say it. In this tool, you can see that there's a learn more button here. And this basically is just kind of a simple little interactive tutorial. So you can see here where it says, okay, enter the project name, and then select the language, select the size, and then enter the keywords that you want in here, and then hit build. So once you're all done entering your wake words, then you hit the build button. It takes about an hour to build a custom wake word. And so in this case, because I've got 2 of them, it's probably a couple hours to do this. So I won't do the build here. I've already done the build, so I'll jump to this tab here. So I've named it Ambiq and Sensory. You can see here it's the same language. The size is the 80K byte. The DSP, the chipset is Ambiq, and then here are the wake words. So it's already been built. So now I have a couple different options with the tool. One is I can just go right to download, or I can say, let me test the recognition on the PC. So I'm doing all this on the PC. And so I can just hit get started here. And then it says, okay, record audio, or I can load in an audio file. So I can just say, okay, sensory. And you can see here that here's the recognition result. Now what we're doing on the PC is we're running that same really small model. So we're not taking taking advantage of the power and the processing capability of the PC. We're saying this is what we would expect the performance to be like on the Ambiq chip as well. Hey, Ambiq. And so you can see both are recognized. Okay, so quick PC test. Yep, this looks good. Now I want to download. So here I check the box saying that I agree with the VoiceHub agreement here. And now it presents me with a couple different options. One is if I've already downloaded the Sensory APK, then here's the file and I can just scan it in. But if I don't have the APK, I start with download application. This QR code, using any standard QR scanner on an Android phone, I scan that. That will load in the Sensory APK that we're using for development and test. So I've already got the APK. So let me go to download again. And then I can pop up my phone here. So here's my phone. So I've just got my phone connected to my computer. So it says, okay, scan this QR code. So on my phone, I open up the little file thing and I do scan QR code. So you can see here's my phone. And now I click that. And right now what it's doing is it's loading in that demo. So now you can see I've got the 2 wake words here. You can see the green line bouncing, representing that it's hearing me talk. And I can just say, okay, sensory, as one of the wake words. And you can see that even though I said it in the sentence with other noise around it, it's still recognized. Hey, Ambiq. Okay, Sensory. So what I did is I created in the space, if I were really doing this, it would have taken about an hour, a little bit more than an hour. I've created 2 custom wake words using the VoiceHub tool. And now I've got it all done. I've tested it on the PC. Yep, it works fine. I've tested it on my Android phone. Yep, this is working great. So then I can go back here and I can say, okay, now I want to download the wake word. So I'm going to go here and then download the wake word. And now what this is going to do is it's going to pop up and it's going to say here, okay, here's my wake word. It's the Ambiq and the Sensory wake word. And then I just save it to a file. And now I turn it over to Ambiq and they say, okay, Ambiq, I've got my tools here. How do I integrate this? So what I want to do is let me introduce you to Mark, and I'll ask Mark to introduce Ambiq, and then Gary will show us how we actually take it from this point and load it onto their demo board. Take it away, Mark.
Thank you. Thanks very much, Jeff. Let me tell you a little bit about the Ambiq approach right now. For those of you who are not familiar with Ambiq, I'd like to give you a brief overview. Ambiq was founded 10 years ago on the premise providing ultra-low power computing at the far edge for battery-powered devices. They take a unique breakthrough approach to that. That approach was lowering the voltage within the chip. So the VDD within the chip is lower than for any of the competitors. We call that sub-threshold power optimized technology. We call it that because the threshold is below the transistor threshold. The result of that is very low power operation. Since power is a function of voltage squared, get a dramatic reduction. The reduction is significant. The reduction is from 4x to 10x in microwatts per megahertz. We've done that with all of our customers. Let me show you the history on that. Ambiq has sold over 100 million devices using this technology. Most of them have been sold in the last couple of years and an accelerating curve of sales per year. These units are now sold into 9 of the 10 top smartwatch and smart band companies in the world, spanning North America, Asia, Europe. Those companies that you see here include Huawei, Garmin, Apple and Vivo, Realme in India, Xiaomi, Citizen, Fossil, across the whole range of types of bands and watches. The same power advantage applies to other products as well. So it works for smart cards, the smart home, for hearables, for bands, for buds. So across the board, it gives you an advantage. And you can choose how you take advantage of that. You can use it for extended battery life. For the smart bands and watches, we've extended life from 2 days to 2 weeks or more. Or you can use it to add features. And I'd like to encourage you to kind of open up your imagination. Sometimes when we talk to people, they have a little trouble understanding how far down we're taking the power and to open themselves up at what might be done with that. So let's take a look at what happens when AI is cost effective for battery powered devices. Take a look at your smart hubs at home. They're all plugged in right now. Start imagining if the smart hubs no longer had to be plugged in, we're battery powered and you can move them around. You have mobile smart hubs, lightweight smart hubs, wherever you chose to put them, inside or outside the home. Looking at TWS, of course, we're all excited about TWS right now and all the things, imaginative things that are being done with it. And moving forward, I know when I travel to China, I'd like to have a translator. Like to have real-time active TWS-based translator. I've used the translators, the latest that are available now, and they don't even approach what we'd like to see. So start with real-time translation, language translation. 3D audio, audio that moves with your head, the latest in 3D audio and the advances for that. Gaming, people are using gaming headsets now. Could they move to TWS? Well, then that brings up ultra-low latency. So as we look at these choices, what's interesting about them, they're not small steps forward. It's not incremental. We're talking about step function changes in processing that are required. And also in terms of communication, it's not just the processing, it's the communication. Each one of those, all three that I mentioned, they all require extremely tight control of latency and low latency. Low latency leads you to shorter communication intervals. It leads you to faster lock times. So at the same time, trying to improve the functionality, you really have to look very creatively how you can stay within your power budget and lower the power required as you're improving the functionality. If we look across to industrial sensors, we want to do anomaly detection. And going down this vector, we want to do anomaly detection, alert the cloud, and have it last for 5 to 10 years. So a whole nother set of requirements in terms of the long battery life. In terms of monitoring, allow ourselves to think about watches. We're all thinking in terms of tracking bands. What if a band did more than track? What if that band also could do its own atmospheric monitoring? What if it could identify if you were in a dangerous situation as you went into it? It might give us more mobility even right now if we had such an imaginative device. So just allow ourselves to keep thinking in terms of what can be done if we drop power by a factor of 4 to 10x. How about coming back to the home? Virtual stickers. How about Alexa stickers or Google stickers or Xiaomi stickers, which you could put anywhere in the home? And perhaps they could have some of that additional environmental monitoring capability we talked about. $10 sticker could be loaded with the latest hardware capabilities and could monitor that for months or years. And let's look across to the remote control. For the billions of remote controls out there, perhaps it's time to drop the push-to-talk paradigm. We've looked at a lot of imaginative approaches for always-on voice, and they have drastically different requirements for the processing capability required. But in each case, they have a certain size battery, and you need a complete right-size solution. By right size, encompassing everything. What are the microwatts that you must live within? What's the megahertz processing you need to do that algorithm? What's the kilobyte floor plan, kilobytes of memory that you need to execute that? And does it fit in terms of my customer's requirements from a dollar and cents viewpoint for my sale price? Furthermore, it's not enough just to do that in one part of the process or one part, one function. You have to cover all the functions from microphones, signal processing, sensor fusion, inference, focus today, security, and connectivity. You need a complete right-size solution that encompasses the whole solution. And that's what Ambiq is about, trying to break the rules, to be radical, and open up new opportunities like this. We've worked closely with Sensory for multiple generations on voice, and I'd like to echo and perhaps add hopefully a little bit of color to some of the things that Jeff was saying. We need a flexible, comprehensive, battery-powered endpoint solution. Jeff was talking about the changes in the way people use things, from push to talk, still there in some devices. It's a little surprising, but still there. Moving to always-on voice. A year ago, people were mostly talking about one wake word. Now Amazon and others are pushing for dual or more wake words. You reach the cloud server that you want. So one word wake word to multiple wake words. And for commands, we used to talk about a few commands, then a dozen commands, and now we talk about dozens of commands for some of our customers. And in particular, when you go across all the use cases in terms of the evolution of voice commands for watch is on a very different trajectory than the evolution of voice commands for earbuds or the evolution of voice commands for your wristwatch. So each one's going at its own pace in frankly somewhat unpredictable directions. And then for the development teams, working with architects, system engineers, product managers, generally or often at the start of the project, they are not sure how they're going to use their device and how much risk they want to take, how much are their customers pulling them in terms of what use model they're going to take. So often the use model itself is not known until well in the project. And then you compound that with the fact that you often don't know the wake words and the commands. And again, a little clear what Jeff said. If you look through these levels, we work with a lot of ODMs. We work with the major ODMs in the world, of course. So starting with the ODMs have multiple OEMs that they're supplying, the companies like Apple and so on, Google and so on. They have multiple OEMs they're providing. And then those OEMs are selling it into multiple continents, with countries with multiple languages. And then in those countries, then they have multiple cloud providers. So you can see it's virtually impossible to know at the beginning of the game exactly what the wake word is, what command set you're going to want. So for multiple reasons, you need to be extremely agile and flexible. And VoiceHub is really an ideal solution for this kind of problem. From our viewpoint, we address this problem with a voice-on-spot reference design. Ambiq has a great group of acoustic architects, engineers, application engineers that work on this together. They together provided a solution that we use that gives you always-on voice and gives you the complete trip, not just for the Alexa or other recognition, and for communications to the cloud and back. So the reference design covers all that. It's based on free RTOS. It has a number of defines, so you can make switches in terms of choosing how you're going to use it, what you're going to include. You can choose one or more digital or analog microphones. The chip itself is in the cartoon at the bottom in the biggest rectangle. The PCM converter, beamforming, noise reduction, keyword detect, and local command. We're going with Sensory VoiceHub. You can do one or both of those. And then in the case where we are going to the cloud, we have a variety of codecs. And we've done a lot of work every step of the way. We look to optimize. And we have an Opus codec that's been optimized and is congruent with the requirements for the Alexa cloud. So we have this complete programmable solution that you can use to create the platform of your dreams. Now for today, we're going to, just like Jeff compacted, we'll compact down. We're going to use the Vesper VM3011 mic. It's a digital mic. Will come in through our PDM to PCM converters, and we use that VoiceHub for keyword detect and for local commands. We have a choice of families. We're several families for Apollo Blue family, Apollo 2, Apollo 3, and Apollo 4. We can start over with Apollo 2. It runs up to 48 megahertz. Apollo 3 has the 48 megahertz in the ultra low power mode, but has a 96 megahertz burst mode. Apollo 4 Blue has taken that farther to 96 megahertz basic ultra low power mode and a 192 megahertz burst mode. You can start to see the increasing emphasis that we're putting on analog and audio. We're going from 2D mics to 8D mics in Apollo 4 Blue, along with 2A mics on the inputs. To support this, the memory that we have 256 kilobytes of RAM in Apollo 2, all the way through 1.8 megabytes in Apollo 4. Flash going from 1 megabyte to 2 megabytes. As we're going through the migration, then we're learning more about the low threshold technology. The circuit designers are getting better and better at that, and the architects are getting better and better at that. In addition, we are following a semiconductor process migration, and we're going from Apollo 3s and 40 nanometer to 22 nanometers in Apollo 4 Blue. Moore's law is still alive and well for embedded, and we are taking advantage of it. So in this case, we're going to use that CPL, the PDM, and the Sensory VoiceHub. And we're going to use Apollo 3 Blue for our demonstration today. I'd like to make one other point, that we're emphasizing how quickly that you can prototype with this, but it's also the same platform. The platform that we're providing is the same platform that has a framework that can use it to take you all the way to production for your own proof of concepts. Point this out in a few ways. One is that they've noticed that the wake word that was created was 80 kilobytes, and Gary's going to create that same size wake word. We've gone through qualification with the major cloud vendors, and we've used an 80 kilobyte wake word. Now, I will say the search point today will probably be a 10. There usually is some adjustment on search point by the time you get through all the FR, false reject, false response accuracy rate testing with the cloud. So there's some adjustments, of course, but the basic framework are well, and there's no big surprises in terms of going from prototype to product. In terms of the load on, I want to mention one other thing on the Sensory model. The Sensory right now, we're testing with the VoiceHub, but in terms of going to a linguistics model, so if you switch from the VoiceHub model, if you find you go to product with that, great. If you need to switch to the linguistics model, then that would be typically at the same size and take you all the way through. For the processor, we're using the Apollo 3 Blue. That runs at 48 megahertz in ultra low mode, but we don't need all the 48 megahertz. We're effectively using less than 24 megahertz. So free RTOS takes several, that's about 20 for the wake word detect. So we're below 24 megahertz. That leaves us a lot of megahertz available for other capabilities like voice fusion, or you may just keep it at the ultra low level. Finally, you not only want to be in low power when you're in state, you want to be in the lowest power state. And what do I mean? I mean that if we can be sleeping, that's the lowest power state of all. So in the demo, and included in something you can take to production, we're including the Vesper VM3011 microphone. So we're below 20 microwatts for the whole system, chip and microphone, when we're in deep sleep, waiting to be waking up. And then we wake up and go into low power mode that we're talking about. So for all the steps, from the sleep to waking up to processing we're showing today we're not showing in terms of communication to the cloud and back. We take the power into account for every step of the way. This is what our hardware platform looks like. This is the EVK itself. It has the Apollo 3 Blue. And with this, I'd like to hand off to Gary Allen for a demo of VoiceHub on Ambiq for you.
Thank you, Mark. You're going to stop presenting, Mark?
Trying here, just a moment. Sorry to. Just a moment, I got here, Gary. Sorry to take so long for that.
That's fine. Okay, thank you, Mark. With Sensory's VoiceHub, it's very easy and quick to generate keywords. And with our VoiceOn Spot platform, it's just as easy to test them out. So the VoiceOn Spot platform is a flexible framework for building devices with wake words and local commands, as well as with BLE connections for cloud integration. So once you've got the files from Jeff, you just drag and drop them into the VoiceHub files into the VoiceOn Spot platform. And then we just simply rebuild the project and run it. So I've zoomed in on the dev board here so you can see, and we're going to use the LEDs to demonstrate which keyword has been detected. And we go. Now it's up and running. You can see the LED just blinking in the background just to show it's awake. Hey, Ambiq. Okay, Sensory. It's that easy. It's very simple, very quick and easy to test out your keyword of choice. But of course, we don't just support keywords. So I'm going to hand it back to Jeff to show how to demonstrate creating a command set as well.
Okay, awesome. Thanks, Gary. That's cool. I love how fast it is to take the model, create it, run it on. And it doesn't have to come from me. Again, with VoiceHubs, it's open platform. So everyone that's watching this and the developers out there can create their own. And then you can see how easy it was to get that running on the Ambiq demo. Just real quick, and I know we're starting to run a little short on time. I wanted to talk just real quickly about the difference between VoiceHub and HandTune. Mark had mentioned that we do both, and we do. So just a couple of quick comparison points. So VoiceHub, there's no real world data. We've created a proprietary approach for synthetic data that we're using for tuning. So therefore, there's no data, there's no tuning, there's no cost. Typically, it's a 24 to 48 hour turnaround time. It's ideal for demos and proof of concepts and some production products. So we've seen some customers that have tested the VoiceHub output and said, this is great, and particularly for close talking and wearables and mobile and those types of things. When I'm using far field, that's where a HandTune model is probably going to outperform it. But our HandTune models are real world data specific to the command set and to the product. It has sensory linguistically tuned down to the phoneme level. There's some NRE involved, obviously, and it's usually 2.5 to 3 weeks to develop a wake word or a command set. And this does provide the best overall performance. But I created a demo, a wake word. I created an Alexa wake word, and provided to Vocalize.ai, who's a third-party testing house, and had them run it through the Amazon certification test. And the VoiceHub model not only met but exceeded the requirements there. So it really is, the output is quite phenomenal. So here I can do a command set, and again I can just type in the name that I want. Here for the wake word, I'll choose the wake word that I just created in the last when I was working just a minute ago. The language, again the size, the platform that I want, and then the command set. So I can just type in commands like bedroom lights on and kitchen lights on, and I keep going through that, and then do the same process of build. So in order to help save some time, so here I've got the Ambiq Sensory wake words that I've already created. I've selected the US English, I've selected the size 80 KB. Here I've typed in all the commands, and I've already built it. So down here again, I can do the testing of the recognition, where I can say the wake word plus the command. So I can say, as an example, okay Sensory, garage lights on. And you can see here that it recognized the phrase that I said here, or hey Ambiq, shut off bedroom. So you can see that it's recognized. So quick test on the PC again, and I say, okay, now I want to go ahead and test this on my mobile phone. So I click OK, and then pull up my mobile phone again here. And here's the Sensory app running on here. So, and you can see I still have the wake words from the last one. So I click scan QR code, and scan that QR code. Now this will load in not only the wake words that I had, but also the command set. So now I've got it all loaded in here, so I can just say, okay Sensory, shut off lights. And you can see that I was able to say both the wake word and the command together. So it's still phrase spotted. This operates just like our HandTune models, and obviously really fast and amazing. Hey Ambiq, garage lights on. Okay Sensory, bedroom lights on. So now I've gone through this process again, created a command set, created the wake words, combined it all together into a single demo app where I can do some testing, kind of product flow, how do I like the flow of it. And then I build it again, or download it, and then I can pass it back over to Gary, who can show you, okay, now take this file and load it onto the Ambiq demo board. Take it away, Gary.
Thanks, Jeff. So just as before, I've dragged and dropped the command files into the VOS platform and built it. And now we're just going to use LEDs to show the different rooms. So, hey Ambiq, bedroom lights on. Okay Sensory, garage lights on. Hey Ambiq, shut off bedroom. Okay Sensory, all lights on. It's that simple. And with that, I'll hand back to Joe.
Okay, thank you, everybody. That concludes the presentation and demonstrations, and now we'll take a few minutes to address questions from the attendees. So the first question I have here, it appears to be for Jeff at Sensory. Do you support Arabic language?
Good question. So I mentioned that we support 24 languages, and Arabic is one of our languages that are supported with our Truly Hands-Free. We don't have Arabic integrated into the VoiceHub as yet, but as we continue to move forward, we continue integrating languages into VoiceHub. So the answer is yes, we support Arabic, not in VoiceHub as yet.
Great, thank you. Next question here looks to be for Ambiq. Does the Ambiq platform support a pre-roll buffer?
Yes, we do. We do support a pre-roll buffer. In terms of definitions and setting up your reference design, you just make that selection for a pre-roll buffer. So you can choose whether you want it or whether you don't. And if you do want it, you can select the length of the pre-roll buffer, which can be up to 500 milliseconds.
Great, thank you. This one again is for Jeff. It says, for wake word, you selected 80 kilobyte size. Would you recommend using even smaller sizes for actual products versus demos?
It's a good question. So the best performance will always be if we run the largest possible wake word model we can. But that has to be defined by the product, by the available memory, by the power requirements. So the smaller you go, the less power and MIPS that are required, but you also tend to give up some of the performance. So it's not really a question between demos and production product. It's really more about what's the production requirement in terms of power and memory that's available. So VoiceHub, the smallest model that we support today is 80 kbyte. In a HandTune model, we can get down as small as 30 kbyte. And there are products in the market today, wearables, that are running our 30 and 40 kbyte models that are HandTune. Eventually, we'll add the capability to further shrink our models on the VoiceHub, but today it starts at 80 kbyte.
Thanks, Jeff. And for our friends at Ambiq, how do I get a development kit?
Sure, just contact us a couple ways. You can send an email to marketing@ambiq.com, or you can go onto the contact section of our website and fill out the form there.
Thank you. Another question here, is VoiceHub app only supported on Android?
Yeah, today for the app, it is Android only. We do support iOS, Linux, Windows PC, and other platforms, but for VoiceHub, the app today is only on Android. So what I demonstrated today is that you can test both on the PC, and then you can also test on the Android. But if you are looking for something to do a quick test on mobile, it's Android.
Thank you. Which tools used to debug MCU Apollo 3?
That's probably one for me. Yeah, we support IAR and Kyle, and also GCC.
Okay, thank you. Another one, I assume VoiceHub exports are not meant to be built into production yet. Is this on the roadmap? By when?
So we actually have some customers that are planning on using VoiceHub outputs for production products. So it's really up to the customer. It's up to, and some of it's defined on the products. As I mentioned, for close talking products where I've got generally a pretty good signal to noise ratio and I don't need to worry about the distance recognition and those things, the VoiceHub output's actually very good. It's better than other automatic tools, and in some of the testing that our customers have done with other wake word providers, it actually is better than the HandTune models that they're doing. So you could use it for production for sure.
Okay, thank you. This is a long one, so bear with me. How can I see a demo, or better yet, play with it myself, actually building out a full voice dialogue?
So I think that's a two-part question. So I'll go first, and I'll turn it over to Mark. So from our perspective, go to our website. There you can sign up to receive the VoiceHub tool. Within VoiceHub, you can do everything that I showed today. And then next month, we'll also introduce our Truly Natural part of that, which will allow you to create a full grammar as well, natural language grammar with NLU and all the outputs and intents that go with that. So with the VoiceHub, you can do exactly what you asked, and then turning it over to Mark on the Ambiq side.
Sure. So then in terms of the hardware, just approach us, the two ways I mentioned. It could be the contact form or our email with marketing, and just approach us, let us contact us, and then we can provide the kits. And when you have the kits, then you're in the same place, that Gary is. With that kit, it's the same kit then. Comes with the processor, the shield, the microphone, everything's there for you to work with. And then you would choose then in terms of your defined statements in your program, in your project, in terms of how you wanted to set that up. You create the binary, load it, including the model that you've got from VoiceHub, and run it.
Okay, thank you. And on VoiceHub, how many commands can an 80 kilobyte model handle?
That's a good question. So when I created the command demo, I selected 80 kbyte, and then as I add commands, it will grow from there. The more commands I add, it's going to grow that memory. It doesn't grow it linearly, but once the model is created, you can see the output size. the VoiceHub, we can't hit a specific memory requirement. We started at a stage like 80 KB, and then it will grow from there. So I didn't look, but my guess is that that command set of 6 commands that I typed in those phrases was probably 85 or 90 KB or something like that. I didn't look, but it does grow a little bit as you add more commands to it. Now, when we hand tune, we can hit a specific size. So if you say, hey, 80 is all I got, that's all you get, we could have 20 commands that fit into an 80 KB size. So there's a little bit difference between the VoiceHub output and a hand tune model. I hope I answered that question.
All right, thanks, Jeff. Is there a demo app for testing BLE communication for voice with the Ambiq development board?
Yes, there is. The reference kit is built with all of that. So the reference kit includes both the audio chain and the communications chain. And we didn't talk a lot about the communications chain today, but that's all provided with the kit.
Thank you.
The BLE radios in the chip.
Okay, and then it looks like we have a final question here. How would Sensory differentiate themselves to Mozilla Common Voice or other open speech recognition platforms?
We work great. Oh wait, actually, I'm not that familiar with Mozilla. Some of the other open source stuff, you know, you're just not going to get the performance that you're seeing out of the VoiceHub. You know, and often we will have companies come to us and say, hey, I started with Sphinx or some of these other open source things, and you know, it's okay, but you know, in this environment and with these accents, and you know, if I'm using it in this way here, it doesn't work as well. And so that's where a lot of our customers will come to us who start with one of these open source solutions and then use it kind of for prototyping because it's free and it's you know, I guess not that hard to use. But now with VoiceHub, I think that's going to change that whole dynamic because now it is free and you get quality recognition out of it. So I would say that's probably the best comparison I can make.
Okay, and then one more VoiceHub question. I assume there's an upload process for larger commands when building a command set. Is that true?
An upload process for building commands. So I'm not sure I understand the question, but let me try and answer it. So so VoiceHub supports up to 20 commands and up to 10 wake words. So I can build 10 wake words, which I wouldn't recommend for a real product, obviously. The more wake words that's on and listening, the greater the chance for a false accept, obviously. For the command side of it, we can support up to 20 different commands, and I could have multiple command sets. So I could have 5 groups of 20 commands if I wanted to, all done with VoiceHub. I'm not sure I understand the upload process. So once I build it, I then have that file, and then in the case, you know, with Ambiq, you know, as Gary was able to show you, I take that file, I build it in there, and now I have something that can run directly on the Ambiq demo board, so I can test and make sure, either using LEDs or you know, I assume I could hook up IOs to it as well and actually control things and whatnot. Gary's shaking his head yes to that. So I think that answers the question. There is a possibility where you could create it, and if the product had an OTA capability or some other method of connecting, then you could say, okay, I want to select this command set for this type of environment or this situation, and it could pull that command set that you developed with VoiceHub or that was hand tuned with Sensory.
Okay, and I think that answers all of our questions, and we're coming up on the top of the hour. So I just want to say thank you to the panelists and also to our attendees. I think it was a very informative session. A really compelling voice solution from 2 great partners, Sensory and Ambiq. A link of the recording will be emailed to everyone that registered. And of course, you could always find more information at sensory.com and ambiq.com. Thanks again to everybody, and goodbye.
Thanks all.
So long.
Bye.